This video, we're going to talk about two left-hand rules, the left-hand generation rule and the left-hand conductor rule. Eventually, we're going to apply these concepts for motor torque and its direction, but right now, just want to concentrate on how these rules work. So let's start with the left-hand generation rule first. As you can see, I already have some stuff set up here. I got a magnetic field. We already know the magnetic field goes from north to south. And then here's a conductor within this field, and then I got the same diagram over here. I already have the properties associated with the fingers over here and for the conductor rule too. So let's start with this one. So the left-hand generation rule, also known as Fleming's left-hand rule, is when you put your fingers like this. So we got our thumb here, our forefinger here, and our center finger here, and they're at 90 degrees from each other. One thing I should mention too is if this is your first video, realize that what I'm doing here is a mirror image of reality. So don't think of it from my perspective, because this is my left hand that I'm holding up, but it may appear to you as my right hand. So the best thing to do is use your left hand, follow all these rules in real time along with me, and just know that what I'm doing here will be a mirror image of what you're doing. And any current that goes into the board for me is going to go into the board for you also. Okay, so let's look at this first little diagram here. And let's say I'm moving the conductor through the magnetic field in this direction. So let's back up just a little bit and talk about why this rule is even important. Well, electrical theory tells us that if we have a conductor and we move it through a magnetic field, we will induce a voltage in that conductor. And if that conductor is a closed circuit, a current will flow. And all the things we'll talk about here is just current to make it easier. So what we're looking at, if there's relative motion between a conductor and a magnetic field, current is going to flow. And what the generation rule does for us is tells us what direction that current is going to go. So let's start with this first diagram here, and let's get our fingers set up, and let's talk about the forefinger is going to represent the magnetic field. The thumb is going to be the thrust or the physical movement of the conductor, and then the center finger is going to actually tell us the current direction. So applying all that to this first diagram, while we have the magnetic field, so that's your forefinger, going down, we have the thrust of the conductor going from left to right, which then the center finger is going to point towards us. Which, how do you draw that on a piece of paper? With a dot. So the current is coming out of the page towards you. We're done. What we're going to do here is step it up one notch, and I'm going to say, well, instead of the conductor moving, let's say the magnetic field moves. So the conductor is stationary, but the magnetic field now is moving from left to right. What do? Well, we don't have that built into our left-hand rule. The thumb is still for thrust. So what we have to do is add one more step and go, well, if we have relative motion between this conductor and this field, and if the magnetic field is moving from left to right, that is the same thing as the conductor moving from right to left in this case. So we have to add that step first. So even though the conductor is not moving in this case, it is the magnetic field, we still have to conceptualize, well, which way would the conductor move, relatively. So that's what this arrow is showing us. Now we apply our left-hand rule. Magnetic field, first finger for the field, going down. The conductor thrust is going from left to right to left, which then brings us the current into the page. And how do we draw that? Like an arrow going into the page, and those are the feathers of the arrow. So there we go. A couple different current directions, a couple different ways of applying the same left-hand generation rule. And that's all we need to know on that. Let's move on to the left-hand conductor rule. This one's even easier. There's only two concepts, but they're quite different. The thumb in this case now is for the current flow, and the fingers are for the field. So how you hold your hand is just basically like you're hitchhiking, And let's look at, let's give this a direction. Let's say the current flow is from, in this case, left to right. So again, we got our thumb going from left to right. Then our fingers are going to show us which direction the magnetic field is. So it's going to go around the conductor this way. That's what our left hand does for us. Now I already have a couple diagrams down here. We have current flow going towards us, and then we have current flow going away from us. So if we use our left hand conductor rule, and the current is going towards us, that would bring this field in a clockwise direction. If the current's away from us, then the field would be in a counterclockwise direction. There you go. Those are two left-hand rules. We're going to apply these concepts to motor torque in future videos. We'll see you then.